Quadratic functions are everywhere around us, from the path of a basketball to the shape of a suspension bridge. Understanding quadratic functions allows us to predict outcomes, analyze patterns, and solve real-world problems. By understanding quadratic functions, their graphs, forms, and solving methods, you gain powerful tools for predicting, modeling, and solving real-world problems. Mastering these ideas builds a foundation for higher-level math and science, and shows us how math connects to the world around us. In this animation, we will explore the vocabulary, tools, and methods needed to work confidently with quadratic functions. Let's start with the basics. A function is a relationship where each input has exactly one output. For example, your phone battery level depends on how long you use it. Quadratic. A term or expression with a variable raised to the second power. Quadratic expression. A math expression that can be written in the form ax squared plus bx plus c. Quadratic function. A function where the highest exponent of the variable is 2. Its graph forms a curved shape called a parabola. Quadratic equation. A math equation where a quadratic expression equals something, often solved to find its roots or zeros. Degree. The highest exponent of a variable in a function. Quadratics are a second-degree function. Representation. A way to show a function, like with a table, graph, or equation. Next, let's explore what a quadratic function looks like. The graph of a quadratic function is called parabolic. It looks like a U, or an upside-down U, which we call a parabola. Understanding these features helps us interpret real-world situations, like predicting the maximum height of a thrown ball. Vertex. The highest or lowest point of a parabola. We can write a quadratic in vertex form. Y equals a times the quantity x minus h squared plus k, where the point hk is the vertex. Axis of symmetry. A vertical line that splits the parabola into two mirror image halves. From a quadratic in standard form, y equals ax squared plus bx plus c, x equals negative b over 2a is the equation of the axis of symmetry. Concavity. The direction the parabola opens. Concavity is upwards for a U shape and downwards for an upside-down U. The sign of the leading coefficient tells the direction. Positive is upward, negative is downward. Maximum. The highest point on a parabola if it opens downwards. Minimum. The lowest point on a parabola if it opens upward. Increasing. The part of the graph where the function values are getting larger. Decreasing. The part of the graph where the function values are getting smaller. Quadratics can be written in different forms that make solving and graphing easier. Standard form. A quadratic written as ax squared plus bx plus c. Vertex form. A quadratic written as a times the quantity x minus h squared plus k, showing the vertex directly. The coordinates of the vertex are the point hk. Leading coefficient. The number in front of x squared that affects the direction and width of the parabola. Vertical shift. A change that moves the parabola up or down on the graph. Horizontal shift. A change that moves the parabola left or right on the graph. These transformations help us model real-life changes, such as adjusting the height of a ramp or the trajectory of a ball. Solving a quadratic equation means finding its roots or zeros, the points where the graph crosses the x-axis. Root. A solution of a quadratic equation. It is where the graph crosses the x-axis. Zeros. Another word for roots, the x-values where a function equals 0. Discriminant. A part of the quadratic formula that tells you how many roots the equation has, b squared minus 4ac. If it is greater than 0, there are 2 real roots. If it is equal to 0, there is 1 real root. If it is less than 0, there are no real solutions. Quadratic Formula. A formula that finds the roots of any quadratic equation using the coefficients a, b, and c. The formula is negative b plus or minus the square root, b squared minus 4ac, all divided by 2a. Completing the square. A method to rewrite a quadratic so you can easily find its vertex or solve it. Some quadratic expressions follow special patterns that make solving them faster. Recognizing these patterns can simplify solving equations and help model real-world scenarios more efficiently. Trinomial. A quadratic with 3 terms, like ax squared plus bx plus c. Perfect square. A trinomial that can be written as the square of a binomial. For example, the quantity x plus 1 squared. Difference of 2 squares. A quadratic in the form a squared minus b squared that can be factored into the quantity a plus b times the quantity a minus b.